Hey guys, I'd like to talk to you about Coulombs Law a little bit, just a little bit more. We've dived into a lot this week, and I thought I'd just put up a video to summarize at least how to use Coulombs Law. All right, so yeah, like we said, so far we've learned about Coulombs Law. What's Coulombs Law? You might be curious. Well, we can use Coulombs Law to find the electric force if we know the charge of two particles, Q1 and Q2, multiplied by K, all right, over R squared, all right, multiplied by K. And K really, K is just a constant, a proportionality constant, similar to how G is in Newton's law of gravitation. All right, so anyway, what's its use? What's the use of Coulomb's law? The main purpose of Coulomb's law is to find the electric force between charges. All right? The main purpose of Coulomb's law is to find the electric force between charges. All right? And see, I say, what should you know about Coulomb's law? Well, you need to be able to manipulate it. If we know the charges, Q1, Q2, and we know R, we can find the electric force, right? Like if I have my Coulomb's law formula here, Ke Q1 Q2 over R squared. If I know R, if I know this guy, I know Q1, I know Q2, we will always know K, because K is a constant. I can solve it, right? And let's just do a quick example here, right? So I have two charges separated by a distance of 0.055 meters, right? In this case, the first thing I do is write out my Coulomb's law equation, all right? And guys, I want you to get into the habit of writing the equation first before you start plugging in numbers. And K, I know K is going to be 9 times 10 to the power 9. Q1 is 13 coulombs. All right, Q2 is 22 coulombs. All right, and then R is going to be 0.055 squared. All right, and this here, I put this in the calculator. I get 4.68 times 10 to the power 13 newtons. That's a really, really large force. Yeah, so yeah, these are relatively big charges, and pretty close together. So that's a pretty large force. Anyway, so now, what if we know the electric force? See, in this question, we didn't know the electric force, so we are able to just plug into our Coulomb's law. But what if we know the electric force? What if we know F, right? What if we know F, right? The two charges, and so what if we know electric force? We know the two charges and want to find the distance they are away from each other. All right, so if we have Coulomb's law again, Fe is equal to K Q1 Q2 over R squared. If we know that constant, well, what if we want to find the distance? All right. Well, in that case, we need to transform our equation to solve for R, not solve for K. All right, so we need to rearrange equation. All right, we need to rearrange equation to find distance. All right, so from there, how can I rearrange this? I want R to be the subject of the formula. I can multiply both sides by R squared. All right, it's going to become R squared. Here the R squared will cancel. It's going to be R squared times Fe. It's going to be equal to K Q1 Q2, right? And then now I want to get R squared alone. In order to make R squared alone, I need to divide by Fe. Fe is just the electric force. That cancels out because if you divide something in the same, if you divide two similar constants, they cancel out. And then this is going to leave me with r squared equals k q1 q2 over fe. And then from here, I can take the square root of both sides because I don't want r squared, I want r. Okay, r is going to be the square root of k q1 q2 over fe. All right, so now I have my equation. All right, so do you see what I'm doing? I'm making my equation first and then I'm plugging in. All right, so I have my equation. So now to find r, all I gotta do is a nice easy plug and chug. I don't need to worry about any numbers. So I know my k is going to be 10 to the 9, 9 times 10 to the 9. My q1 is 2 coulombs, and my q2 is 4 coulombs. My fe is 150 newtons. So what's my r? I put it in the calculator. Again, it's humongously big, 21,900 meters. All right? So that's how we find r. Okay. So what if we know the distance, all right? What if we know the distance already and we know the force, but we want to find the charge of one charge? All right, let me write Coulombs law here again. Fe is equal to k q1 q2 over r squared. So let's say we know the force, yeah? We know the force, we know r, we always know k, and we know q2. What if we want to find q1? What should I do? I gotta rearrange my equation. Again, I gotta make q1 the subject of the formula, all right? So what if I want to find q1? So let's go again. We need to do the same thing. Multiply r to both sides of the equation. I get r squared fe is equal to k q1 q2, all right? And then now, if I want to get q1 alone, I need to divide this by k q2 over k q2. Cancel, this will cancel out. So I can get q1 alone. To get a variable alone, I can just divide by whatever is around it to get rid of it. All right? So then this is going to become r squared fe over k q2. It's going to be equal to q1. I now have a formula. All right? So remember, here I have some values to try. Let's say I have Fe equals to 1500 newtons, R is 10 meters, K is 10 to the 9, and Q, I want this to be Q2. Q2 is 3 coulombs, right? I gotta do is plug in. I made my equation, now I plug in. All right? So 10, I'm gonna say R is 10, so 10 squared. Fe is 1500 over K. K is 9 times 10 to the 9. All right, and then Q2 is 3 coulombs. All right, I put this in the calculator. I get, so it's going to be, Q1 equals to that. So, 3 coulombs. If I put it in the calculator, I get 5.56 times 10 to the minus 7. And boom, there's my equation. So here, the point of all of this is to just make you realize that we can use Coulombs law for more than just the force, all right? For more than just to find the force. It's a game, or it's really a game of, can you find what we don't know from everything you already know, all right? And here's some important relationships to note about Coulombs law, all right? Notice that the inverse square relationship, all right? This is called the inverse square relationship, all right? So Q1, I'm going to write Coulombs law again just to elaborate it for you. The inverse square relationship between force and distance, all right? The inverse square relationship between force and distance. All right, so distance is known as r, right? So if r gets big, all right, if r gets big, imagine if r gets big. If r gets big, right? That means the denominator is really big. So because the denominator is really big, all right, the fraction, the whole number, the value of the fraction becomes small, right? Right? Think about it. Think about it as trying to fit a very big loaf of bread into a very small plastic. All right? That's what this is. If R gets really big, the F will become very, very, very small. All right? F becomes very, very small. And because F is small, all right, as R gets big, we say they have an inverse squared relationship. All right? And the square is just there to tell you that if R doubles distance, then you're going to, the force will reduce its distance by the inverse of doubled squared. I don't know if that makes sense. So let's say if I double my distance, right, then I'm going to have a quarter of the force that I had. All right, I'll explain more of that in class. Direct proportionality to charge. Well, again, I'm going to write my formula here. Let's look at the second guy. Fe is equal to K Q1 Q2 over R squared, right? So the direct proportionality to charge. Q1, if I double any of my charges, right? If I double any of the charges, it means I got to put a 2 in front of any of the charges. But what I'm doing really is literally doubling my force. All right? All right? So there's a direct proportionality relationship. If I triple any of the charges, I'm tripling my force. If I quadruple any of the charges, I quadruple my force. It goes like that. All right? So, yeah. So, doubling charge equals doubling force. All right? And tripling charge equals tripling charge equals tripling force. All right? And so on and so forth. If I 4 times my charge, I'm going to 4 times my force. There's that relationship. All right? And the last thing you should know, right, if one charge is negative and the other is positive, the force is attractive. All right? The force is attractive. And if both charges have the same sign, right, negative and negative, or positive and positive, right, the force is repulsive. All right? So those are some things you need to know about Coulombs Law, all right, that I want you to be a master of, so to say. I've put a quiz on Thursday. It's a major quiz. It's going to be on everything we've done last week and what we learned on Monday, all right? Good luck, guys. I know you can do it. Bye.